Hello everybody, this is Prabhat Kumar once again welcoming you to on Priyan classes. As I have stated earlier in my previous classes that the chapter of derivatives will be divided into three parts. Two parts I have already uploaded, and this is the third part which today I am going to discuss with you. In this part I shall be explaining about how to differentiate some more kinds of functions like implicit functions or logarithmic functions. So in these these type of functions, what procedure we have to take, or what should be the way to treat such questions, I shall be explaining. So let's start with the implicit functions. What are implicit functions in differentiation? Okay, so I am starting with implicit function. Now, first of all, let me explain you what are implicit functions. Implicit functions are those functions where x and y are related in such a way that y cannot be easily or conveniently expressed as a function of x, or I should say directly as a function of x. In this cases, there we have got two methods to solve it. One is by substitution method, and other is by directly differentiating it. Okay, so what I do, so implicit function is what? Where x and y, like if you take 3x plus 4xy plus y square equal to, let's take it as 42. Okay, so this is for example of implicit function where y can be expressed as a function of x, but it will be more difficult. The expression will become more tedious or more cumbersome. So for you to differentiate. So what should we do now? I will do what? Remember one thing, whenever I have to find out, because in this case, what I have to find out? My purpose is to find out dy by dx, that is rate of change of y whenever there is a change in x. So what I do is I just go on differentiating, directly differentiator. Okay, I will directly differentiate it. So when I differentiate the first part, while differentiating, when I differentiate the first part, what I get? 3 is the constant number, and differentiating x with respect to x, the answer will be 1. Okay, so now plus again 4 is the constant term. Now for these two, I will use product rule. So by product rule, what is my product rule? First function multiplied by differentiation of second, that is dy by dx. Okay, plus second function multiplied by differentiation of first, so that is 1 plus y square. Now I will differentiate it, taking y, assuming y as variable. So first I will differentiate y, that will y square, so it will be 2y, and then there will be dy by dx also. And what about right hand side? Right hand side I have got a constant number. Okay, so if it is a constant number, that means the differential coefficient will be 0. Now I have to, what I get is 3 plus 4x into dy by dx plus 4y plus 2y dy by dx equal to 0. Okay, for these two, now just rearranging and simplifying. So what I get is 4x plus 2y multiplied by dy by dx from these two terms, and remaining 2 I will transfer to the other side, that is minus 3 plus 2y. Okay, so now what I get? Dy by dx equal to minus 3 plus 2y divided by 4x plus 2y. So this is the way, this is the simplest way to differentiate an implicit function. I will take one more example for this. So the another example Another example, let's take, suppose that it is given, find or differentiate sine y. Okay, find, or I have to set like differentiate with respect to x. What? You have to differentiate sine y. Okay, so now in this case I will substitute, just let z is equal to sine y. Okay, z is equal to sine y. So what will be dz by dy? So dz by dy will be, means I am not differentiating it with respect to x, I am differentiating it with respect to y. So this will become cos y. Okay. Now what I have to find out? I have to find out d by dx of sine y. That means what it is? It is actually sine y is what? Z. So I have to find out dz by dx. Okay. So now instead of dz by dx, what I get is, I can write it as dz by dy multiplied by dy by dx. Okay. And this dz by dy I have already calculated. This is cos y. So this is what? Cos y multiplied by dy by dx. So d by dx of sine x is equal to cos y multiplied by dy by dx. That is the simple way, that just differentiate it, assuming it to be a one function, and then differentiate it. Okay, so now these are the two methods. Now I will explain how to do with the logarithmic functions. Now I'm going to explain you how to differentiate a function involving logs. But before I go for that, I would like to explain one more thing. Suppose that what will be equal to, if y is equal to log x, then what will be dy by dx. Okay, first, this is the base for this method, because you know, in case, what is the base? Base is E, that is the Napier's constant. Okay, so now if this is so, this implies that e raised to the power y is equal to what? X. Okay, as I have been doing in the implicit function, I will differentiate this. So differentiate with respect to x. So what I get? E raised to the power y multiplied by dy by dx. Why? Because you know that dy by dx or d by dx of e raised to the power x is equal to what? It is simply e raised to the power x only. This you must have done earlier also. So similarly, so when I differentiate e raised to the power y, it will be e raised to the power y, and then y will also be differentiated. So dy by dx, and this side differentiating x, I will be getting 1. So dy by dx is equal to 1 by e raised to the power y. And what is e raised to the power y? It is x. So it is 1 by x. So d by dx of log x is equal to 1 by x. And remember, for these things, always the base of the logarithm is not 10, but it is always e. It is always e, that is Napier's constant. It is never taken as 10 unless and until it has been specifically mentioned. Okay, so now let's move on to our next part, that is the how to explain or how to differentiate functions involving logs or using the logarithms. Now suppose that y is being expressed as fx, and this fx is raised to the power of another function, that is gx. Now how will we do it? Okay, so when I take logarithm of both sides to base e, when I take logarithm of both sides, so taking logarithm of both sides, what I get? Log of y will be equal to log of fx raised to the power gx, or I can also write it as log y is equal to gx multiplied by logarithm of fx. Okay, by taking logs I get this value, this equation I am getting. Now since I have to find out dy by dx, okay, that means I have to differentiate this function. So what I will do is I will now differentiate it. So from left hand side, as you know, it will become 1 by y multiplied by dy by dx. Okay, and on right hand side, what will happen? I can use product rule. Okay, I can use product rule, and see, this is not just only product rule, it is actually a mixture of product rule as well as the system of implicit functions. So by product rule, what I get is gx, that is first function, multiplied by differentiation of second function. Okay, so what it is, 1 by fx multiplied by differentiation of fx. Okay, that is f dash x. I can write it for the sake of convenience, and then plus second function log of fx multiplied by g dash x. That is differential of this thing. Okay, now just so my dy by dx will be what? Y multiplied by gx, or gx by fx multiplied by f dash x, plus log of fx multiplied by g dash x. So this is the way that I have to find out. Now I will take one or two examples also for this, so that it can be better understood by you. So just remember this thing, this is the base that we have to follow. Okay, let's take an example. Suppose that I have been given that y is equal to x raised to the power x. Now see, this is one function, this is another function. Y is equal to x raised to the power x. So directly differentiation is not possible. So what I will take? I will take the help of logarithms. Now in logarithms, if I take logs, so it will become log y equal to x log x. Okay, log x will be, this x will come there, and then there will be logarithm of x. So this is now if when I differentiate this, what I get is, this is, when I differentiate, I get 1 by y dy by dx equal to, again, product rule. So first function multiplied by differentiation of second function plus second function multiplied by differentiation of first function. So what I get, 1 by y equal to, or 1 by y into dy by dx is equal to, this cancelled, 1 plus log x. So what is dy by dx? Equal to y multiplied by 1 plus log x, or I can say d by dx of x raised to the power x is equal to x raised to the power x multiplied by 1 plus log x. Very simple. So I don't think there should be any problem involving. Questions may be longer. This logarithms may be longer. Maybe you may have to take logarithms 2 times or 3 times. Maybe. So don't worry. Just go on step by step. Proceed step by step, and you are going to have the answer right away. Okay. So let's now proceed to the next topic, that is dealing with the parametric functions also. Now, what are parametric functions? Parametric functions are where x and y, remember, we have to find out dy by dx in each case. Okay, so when both x and y, or y is not defined as a function of x, or x and y are not directly related, so in that case what happens, both x and y are defined as functions of a third parameter. Functions of a third parameter, that is, you may take z or you may take t, whatever it is. Okay, so x and y, suppose that I am given that y is equal to f of z. Okay, y is given as f of z and x is given as g of z. Two different functions. And I am given that find dy by dx. Okay, what you will do in such cases, normally I will take the first equation. This is first equation, this is second equation. I will say differentiate both equations with respect to not x, but with respect to that third parameter, that is z. So I will differentiate it with respect to z. So when I differentiate it with respect to z, what I get? Dy by dz equal to f dash z. Okay. Similarly, dx by dz will be equal to g dash z. Okay. So now what I have to find out? I have to find out dy by dx. I can write it as dy by dividing both numerator and denominator by dz. So I will write it as dz divided by dx by dz. Now both these values I have got. I know what is dy by dz. I know what is dx by dz. So when I substitute this will become f dash z divided by g dash z. So this is your dy by dx. I shall take one example also on this. Okay, I will be taking one example, but before this I have to rub the board. Now suppose that it is given that x is equal to at square. This is the very normal way in physics. You must have studied about these things. And y is given as 2 times at. Okay, where a is a constant, acceleration, that you know. Time is only the variable there. Okay, so I have to find out dy by dx. So first I will differentiate this. So from there, what I get? Dx by dt equal to a multiplied by 2t. Okay, so dx by dt is equal to 2at. Again, from there, dy by dt equal to 2 into a into 1. So dy by dt is equal to 2a. Got it? Now what I have to find out? Dy by dx. As I said, I will divide both numerator and denominator by dt, the third variable. So dy by dt divided by dx by dt. and that is what? dy by dt is what? 2a, and dx by dt is what? 2at. So these got cancelled. So dy by dx is 1 by t. The very simple method. There is only the basic rules you have to remember before differentiating, and these are the simple tricks that you can use, or simple methods that you can use for differentiating such kind of functions where both x and y are defined as a function of, or as functions of, a third variable. Okay, so in that case, there is one very small things now remaining in the chapter, and that is about the functions. When a function is to be differentiated with respect to another function, there is not much difference from this. A function has to be differentiated with respect to another function. It is just like this parametric functions. That is a very simple thing. Here also, this is one function, this is a function of t, this is also as a function of t. So there also you will be getting two different functions, and you have to differentiate one function with respect to another function, as I have done there. Again, you have to differentiate both of them separately and then use any one of the method to differentiate, and you will be getting the differential coefficient of whatever you are required. So this is all I think in the chapter of differentiation. I have discussed all in my three videos, and you must have understood. I hope it would be helpful for all of you. And before I go, I would once again request you, all of you, to please subscribe, like, subscribe, and press the bell icon of my video, so that you can be getting more and more updates on my upcoming videos. Upcoming videos will be on some other chapters. Let me see what chapters are left in the syllabus, and within 1 or 2 days or within few days I will be uploading other chapters also. Okay, so goodbye. Thank you.